Good morning, my dear student. I am Suman Bhattacharya. We are learning the course on the operating systems. So, in the course, these are the total syllabus of the course. So, in this course, there have actually the 6 modules are there. So first module, that is introductory part, and then the second module, that is process. So what is process and how to create the process and different type of process scheduling algorithm, then the process management systems, and then your deadlocks, and then memory management. So two type of memory management are there. One is our main memory management and virtual memory, then the IO management of IO devices, and file management and disk management. So this is our total entire syllabus of the course. And after the learning of the course, the students are able to understand that actually what is the concept of operating systems and the basic structure of operating systems, the functionality and the computer systems. And after that they can learn about your process management and memory management portions. So in the process management system, that they can understand that what is process and schedule different type of process scheduling algorithms, synchronizations, how to synchronize with their process, and deadlocks. And then the memory management portions, they can understand that that is the paging, segmentations, and your virtual memory concept, then storage management, IO management, and lastly your security and the protections for required for your operating systems. So these are the actually outcomes they can able to understand after learning of the total entire course. These are the textbooks are here and the reference books, so student can learn from there also. Then today I will start the first chapter, that is the introduction portions. So now introduction portions, so student can understand that what is actually operating systems and what do operating systems, and the basics idea of the computer organization and architecture part. So you in your previous semester you already completed the course of your computer organization and architecture, that is the basic fundamental of what are the components are present in our computer system, so they can understand, and your operating system structures and operating system different type of operation, and your what is the actually the process, the management system, the process management. So basic things you can understand from the introductory part. Now your objective of your operating systems, because this is the basics and the fundamental and the requirement course of the core course of your computer science of engineering disciplines. And if you learn this course and you can, that is the very and it is also the interesting subjects, and in your GATE exam, so the maximum the question will be coming from your operating system also. So they can if you learn this, then that will be the easier for your GATE exam and other competitive exam also. And from this regarding this, then your major student can what is the actually the operating system, the objectives of your operating systems. They have the major of operating system, the component they can understand, and your basics operations, that is your how the computer will works, and how we can access your hardware resources easily from the user interface, so they can understand. Now what is actually operating system, and what is the purpose or the operations of your operating system. So in the operating system actually is a manager. So manager means they can manage the resources with their users. So in a users they cannot access directly to the resources our computer systems. So you know that in our computer system, that is actually the 4 major resource is presence. So one is that is the CPU. CPU is our central processing unit. So this is a heart of your computer. Without CPU, that is your system will not works. So CPU is the main and then the except the CPU, then the memory is our the vital part. You know that two type of actually memory are there. So one is our main memory. So in the main memory there have the data and the files are loaded or the stored, and or we can access the data from the your main memory. So CPU can directly access the main memory as per they can fetch the data from the main memory to your CPU, and then the process will be works on. And then after that, if the CPU wants to store the some of the data to the memory, then the memory will be allocated and then it will be stored. Then the yours another memory, so that is our storage memory, or we can say that is the secondary memory. So in the secondary memory, for example of secondary memory, you know that your hard disk and your tape drive, magnetic tape, or your different type of peripherals. So that these are the your secondary memory where we can store the data in the for the permanently, and but here the one obstacle is that the CPU cannot directly access the secondary memory. So if the CPU wants to access, then they can access your device driver for via your instructions. So then the from the secondary memory to data will be stored into the your primary memory, and then from the primary memory CPU can access. So this via communication will be happen. So it is also the important of the resources, because if you want to store the data for the future reference, then we can store the data into the secondary memory. And last resource is your IO devices. So IO means the input output device. So we know that that is the several types of your input output device are present. So if the CPU want to take in the inputs from your input devices from the interface, then CPU cannot directly access. So via your device driver they can send your instruction to your drivers, and via the driver the data will fetch and data will be received, and then the CPU will perform their operations into the CPU, and then the value will be stored, or if you want to display the results, then your output device will be worked. So these are the devices are required. But here one thing that happened, that all the access or the process via the operating system can do. So that is the CPU in the instruction will be the operating systems that they send the instruction to the CPU, then the operation will be performed. Otherwise this will be not happen. So other things, and in our operating systems there have actually the operating system is in between your hardware. So these are the hardware components, and another part is there, that is your applications program. So application programs where we say that for example of the word processor, compiler, and the web browsers. So all are our application program. The user access the application program, but the user cannot directly access to your hardware, that is the hardware your resources. So if the user want to access the hardware resources, then the user first send to the commands to your application program, and application program via operating system they can access the resources, otherwise not. If the operating system give the permissions to the to allocate the resource, then the application program allocate this, otherwise not. So you have to remember that suppose there is the CPU by one CPU is present in our single computer. So if the CPU or this resource are busy for the some of the tasks, then the another process are waiting. So CPU, that is the operating system, is it is a very much intelligence that they can take the decisions from which process will take the or get the chance to the CPU, and there have several type of management system, management processing or management algorithm is there, that is process management algorithm or CPU scheduling algorithm. So they can access via the operating system. So this operating system can do this other process. Now this is our pictorial view. So for example, that is the n number of users are there. So in the n number of users, so suppose for say this is our user 1. So in the user 1 and they access the our suppose the device the compiler, but the compiler if the compiler so user 1 write down their some of the problem about the programming to the your compiler editors. Now when the user 1 execute this, so then this instruction will be fetched one by one. So this instruction is called the your the process or instruction, or this program is called the process. Now suppose this compiler have the generate the one process, and this process is want to access the suppose one of the component of the hardware, that is CPU, they can want to access, but it's not. And same time the another user, suppose user 2, they have the another assembler, and we have to assembler will run the program, and the assembler is also the one to access the same CPU at this time. But what happened? So it's never possible, because there is a one CPU is there. So this compiler, if we want to access the CPU, then assembler did not get the chance to access this. So operating system can take the decision which the process will be first get the chance to get the CPU and will not get. And after finishing this, then the assembler to save the request, assembler will get the chance. But and it is also, you have to remember that suppose that this process 1 will get process P1 will get the longer time for accessing the CPU. So assembler is wait for this long time, so this will be not supposed to happen. So then operating system will take the decision, so they can stop the process 1 immediately, and then that is this time is context switch will be happened. So now process 1 will be moved to the our waiting state, and then process P2 are come to the that is the execution state of the your accessing state of the operating system. So this way actually the all n numbers of users are there, so they can access the via their compromise or process in our operating system, or the different follow the your operating system's algorithms. Now there is a what are the actually the users view of our computers. So we know the various of the according of interface based on the uses, and most of the system are designed for the one user to monopolize in the resource. Means that you have to maximize our work for the operating systems and user to performing. And second is our operating system is designed mostly for easy of use, because the user cannot directly access to our resource. So that the user cannot think that what happened inside the in our systems. So that is they can suppose the run the your or the execute your programs, and they can get the results. But inside the how to that management, that is the which resource will be accessed, and which maximize utilization of the resource. Means that CPU cannot be idle if there is a maximum number of processors are present, but maximum processors are waiting, but the CPU are idle, so it's never happened. So the operating system will be managed those things. So how to access your CPU is maximum time, so this CPU utilization will be taken. Now second is our some of the user interface to your mainframe or the mini computer. So in our mini computer, that is the one system is there. So one CPU or the one memory devices. So now how to the operating system will be make a design, or that is the maximize of the resource can be used maximum time to maximum so this design will be happen. Now for the so in the main computer there have a problem, because suppose there is a multiple of the process are waiting for a long time, but only one CPU, so that will be a problem. That's why that is your distributed computer system will be generated. So in the distributed computer systems there have suppose there in the distributed system, so n number of CPU are there. So total n number of CPU are interconnected to our one network. Okay, suppose this is the one CPU, this is another CPU, this is the one system, these are the systems. So all the system are interconnected to each another, and you know that each of the systems have same type of resource, that is the CPU, memory, IO, devices, so all other resources are present. So now, and this connected via your LAN or WAN network, so the computer, that is a via network, they are connected. Now if the some of the resource want to access the some of the database or the some of the your files, then they can access the suppose the its own CPU are busy, so they can access the another CPU also if it is a shared mode or shared basis. And suppose, for example, of the another example, for suppose the one large database are there. So now we can distribute the large database into the small, divide into the small database, and each of the database will be distributed to the suppose among the connected networks. Okay, now we can access the from the any of the systems of the which is connected to the network. Then we can suppose the want to access the some of the data from the our database, so they can send the request to the network and they can search the where the database, so this data or the database query or this presence, then they can fetch the data from theirs. So now here's one problem will be created. Suppose the there is a duplications. Duplication means that suppose the same our data are present in the both the database in the two different systems. So now when the user send the request to the connect from the any of the connected your devices, then the two data will be coming from the there is the two systems, because these data are present in the both the systems. So this time the problem also operating system manage this, how to manage or how to remove these duplications, so they can find out or they can find out. So entire these things will be that is the distributed computer system will be there. So now they can resolve their these problems, and there is a maximum time resource will be utilized. Some of resource, suppose some of the busy, for some of the resource are busy, and then we can complete their tasks via using the another your another device, our resource which is right now it is a free or the idle mode, so they can access this now. And you can handle your systems, that is the operating system can design for the individual usability, and embedded systems are also nowadays it designed for the run, because the embedded systems that is a small devices, and we can run or that is a movable or we can use anywhere. Okay, so this portability will be the easy. So these are the user view of your computer systems. Now in the concept of our system view of the computer systems, so in the system view, the operating system is a program, and it most of the involved in our hardware, so all of the hardware are involved, and operating system is a resource allocator. So operating system first task is our allocate the resource. So which resource are now free, then they can allocate the resources, and which is busy, so they can take the decisions, and if it is a not free, then you can free it. If it is a complete their task, and then we can get that we get the second chance for the another process can access the same these free resources. And that means this management of all the resources will be done by our operating systems. Operating system can decide between your conflicting request for their efficiency and the fear of the resource uses. So it's not happen that suppose the one process is waiting for long time, and they can send the request, and other process can enter to the or they can access the resource. So this never happens. So this there have the fair resource utilization also there, and there is a no conflict request. So they can take the decision which is the prominent. And the operating system is a control program. So control means that is suppose the one program is there. So now execute the program in a sequential manner. So this controls, and suppose that there is some of the error will be occurred in our then we can resolve the errors. Operating system can resolve the errors, and for the error and that is the improper use of your computers. Now this is actually the definition. So actually I already told that it is a managers actually, like the system manager. So they can manage your process, they can manage the memory, they can manage your IO devices. So via this everything as actually so everything a vendor. So and shipped when you order to our operating system. So we give the instructions, the operating system give the instruction to which the next execution will be happened. Okay, so these are the and here is in the kernel is our main the execution terminal. So there is the your kernel mode, so you can the operating system can perform. Now your computer system, that is in our computer system organization portion, so we are taught in our previous semester, that is the what are the phases. Your CPU is our one of the part, then your disk. So in the disk via the controller, so this device controller will perform. So CPU, if I want to access the disk, so via CPU want to access the disk, then via your disk controller they can access this, otherwise no. So CPU cannot directly access your disk. Same way your suppose CPU want to access your input or output devices, so these are the input output devices, so via your controller they can the CPU can access, otherwise not. So at memory, but the memory the CPU can access directly the memory, main memory, they can access the memory for the fetching the data or the storing the data, so they can access this. Now how the computer will be start up or your execution. So when we load the operating systems into our systems, then when you load this, then actually the operating system is a program. Operating system, the operating is a program, and this program will be executed, and when it is executed, then inside the program, actual operating system, then there have several algorithms, and they can take the decision what in the present scenario, so what will be the taken the actions, or what will be the take the decision which will be there. So operating system can take this. So so this program will be first loaded into our ROM, because we know the ROM or your EPROM is our non-volatile memory. So, okay, so they are the primary memory, and it is stored permanently, but it is not stored into the your RAM or the memory, because the memory is a volatile. When you turn off our system, then this will be erased. So the primary, if I store the operating system into the main memory, so now each and every after the power off, then your your operating system will be erased or deleted, and then again you have to reload. Reload is required, and then your computer will be start up. So that's why all the programs of the operating system will be loaded first into the ROMs when you loaded it. Now when the computer will be start from the ROM, your operating system will be again load to our main memory. So in the main memory, then the operating system will be executed or the boot up, and then all the aspects of all will be the initialized, and then the load operating system will be loaded, and then the kernel will be start. The kernel will be run, and they can wait for the all the signals, that is the hardware all are the hardware are active or not, so they can check, and the software triggers or the internet via the system call, they can check it, and then your system will be, if there is some of the error will be there, they can solve it. Okay, so this will be happen. Now suppose that you can check your interrupt timeline, because when the CPU is working, then the CPU is working, and this time the IO another process will be busy. Okay, and then the CPU will be release this, then so this will be checked via this your interrupt. Then you know that your storage structure means that our RAM, that is a main memory, and then we know that the von Neumann concept in our architecture portion. So in the previous semester we have to talk about that, so how the von Neumann architecture will works. So you know that the load instruction load or the instruction from the main memory to first your instruction register, that is will be loaded, then and we can the operand will be fetched from your memory to your internal register. So in this time the internal register are used, and you store the instructions and the data in your main memory. So always the first there have no secondary concept. Okay, so and the results and maybe your return back to our main memory. So main memory is useful, and they are but useful, and it is not a large enough to space to hold all the programs and the data, and it is also a volatile memory, I was told, and when the power will be lost, then all the data will be. And the secondary storage is actually used for permanently stored, and it is a huge volume, and but it is a cost effective, but it is a cost is more than your main memory, and its speed is slower than your main memory. These are the storage device hierarchy. So that is registers is our smallest actually your size. Then your cache, the main memory, that will be the size will be the increasing order. So this is our increasing order of the main memory size, but your access time will be the reverse way. So now register access time is faster than your cache, and cache access time is faster than the main memory. So this is our access time. Now we move to your IO structure questions. So input output structure. So that is storage is not is only your main type of your IO devices, and each device are connected to a via controller. I already told that is via the controller. So CPU, if and there is a connected via the bus is there. So each of the bus is connected to the devices. So via controller bus, the CPU can access your devices, any of the input or output devices, and the device driver for each they have the controller. They can actually all the details, all the informations are stored or kept into your controller, and you say that is busy or not. And there is also the buffer is also there. Each of the input devices buffer are present, because the suppose the CPU send the some of the or access the data, but that CPU is faster than your IO devices. So IO devices are slower. So first from the IO devices, all the data or the input or output data will be stored for buffer, and from the buffer to data will be fetched to our access to the CPU or your memory. You can store main memory. So this way data will be stored, and there as a IO your operation will your device driver load to your controller register. So register, that is the memory I already told, that is a buffer memory. So they can access, and then it will be executed. And one main is that there is a DMA, so that is a direct memory access. So in the direct memory access means that it directly we access your memory from the device. So device controller, that is they can transfer your data or the storage to your data or the values to the memory, or they can access from your memory directly from the memory. So that is via the DMA. So CPU send the instruction to our controller, and then the that is device will be access the data from your memory or to the memory, from the memory or to the memory. So they can access this. But if the CPU not send to any instruction, then it is never happened. So that will be the interrupt will be happen for your blocking or transfer. So then if there is a transfer will be there, so now they can send this. So this is actually the pictorial view. So there is a CPU. So CPU, and this is our actually the main memory. So this is our main memory portions. So and this is our CPU. Okay, so now in the CPU total, that is a n number of processors are there. Okay, so n number of processors are there. So now each of the process one by one process will be executed. So now here you see that is a CPU first communicate. If CPU want to communicate to our memory, suppose CPU want to store the instructions or getting the instruction from your memory. So first they search this instruction are present into the cache or not. If that is instruction are present in the cache, or they can get the information, then they can access the information from the cache. If it is not present in the cache, then they send the request or send the instruction to our main memory, and they can find out this instruction are present where, and they can get after getting they can fetch it. Or same way the storing process also. Suppose the CPU want to store the sum of the data, so first it will be stored into the cache, and then your instruction will be stored into the memory. So cache is in between your memory and the CPU, because for the faster process, and then and same way the data can be moved from the bidirectional way. And this is another is our input output devices. So input output devices, if the data is communicated directly is required, they can access the data from the CPU, or they can send the data after processing. Suppose they can want to display the results, or for the output purpose they can send the data to the devices directly, or there is a suppose or the CPU send the instructions that, or send the request to store the data directly to the memory, not via. So this time CPU send the instructions or send the request to the device, and then the DMA controller will be active. Then the DMA controller will be active, and then the data will be stored or data will be fetched. So this it will be happen. Now your computer system architecture. So actually there is a single process systems. So in our single process system, that from your PDA, that is a personal computer to your mainframe computer, and or that is a one process is there. So single process is there, and one user can access the one process. So the single user is there, so that will be created so many problem, because suppose there is a more number of actually the process are present, so they are wait for longer time. So that is a, so then the CPU can manage the your how to manage your which process will be get the first chance and which process will be second chance, so they can. But the multiprocessor system is that is a multiple actually system are connected, multiple and then your CPU can switch, and CPU can switch the or the context switch will be happen. So one process to other process. So they have to in that case the your that will be increases. Okay, so that is throughput will be increases, and economic scale that is economical values will be the of scale up, and it is also the increase their reliability. Okay, so that is one of the multiprocessor systems. And your fault tolerance, that is your that is no error or fault will be tolerated. So that's why your increase the reliability. So if there is error will be occurs, and operating system will be resolve this. Then your asymmetric your multiprocessor systems. So each process assigned to your specific task, and there is your symmetric is the all process perform the tasks within the operating systems. Now your symmetric your multiprocessor architecture. So here the n number of CPU will be connected to the one at the memory, that is the memory at the shared mode. Now how to manage? So suppose the one CPU and it is also called your multi-core CPU chip. So in the multi-core CPU or multi-core. So in the that is a multiple your compute the cores, or actually your access the one chip. So that is a shared mode. So now suppose the one CPU will be busy or access your main memory, then the other will be other CPU are waiting state. Okay, so that actually it is a virtually we say that all the CPU are busy. So in this time the IO, suppose some of the CPU are working to your memory, access the memory, then the another CPU are busy for your another process. Okay, so it's never happened that both are the CPU are busy at a time. Then your clustering system, the cluster of the system is that it is a composed of your two or more individual system, or the coupled together via a LAN. So that is the via LAN network, they are interconnected to each another. And it is a provide your high availability, because because if the network is connected, then and any of the place you can your system in the geo in the connected to the network, so we can access any of the system from any of the place of geo place. So we can access this. And then suppose this availability also there, so it is not required to suppose if I want to access the machines, these machines or this device from the anywhere. So, okay, so they can access this if it is connected. So if the network is failed or network is not present, that will be create the problem, otherwise not. Then your asymmetric clustering, also asymmetric clustering as the one node active and the other is our monitoring or the awaiting state. Okay, so this is called the after completion of the active node, then the other will get the chance. So this is our your asymmetric clustering. This is your asymmetric clustering, that is the one node is our active, and then your symmetric clustering. In the symmetric clustering is our as all the nodes are active. Okay, all the nodes are active, and it's able to take the one more program if one is failed. Suppose the one your node is failed the execute the program, then the other can get the chance. Okay, so symmetric is the best way. Then the clustering cannot allow your multiple node to access the same data unless it is a your distributed log management systems. Okay, so if it is a there is no barrier is there, then they can access this. So these are the for your clustering systems. Now the operating system, your system structure actually. So we know one is our single computer system, that is the one system is there and one CPU. Multi-programming, that is the multi-programming means that there is a multi-user. The single user cannot keep your CPU and IO devices busy at all the times. Okay, so that is a multi-program. It is needed for your efficiency, because as in the single users that have create the problem, because we see that suppose the one program one CPU is accessed, then the all time it is busy, so they cannot access this. So the multi-programming is and this job will be, that is this time CPU always has the one to execute. Suppose the one program is finished, then the another program is waiting program, that they can get the chance. So all time CPU will be busy, and it is your subset of your total job in the systems is kept into the memory, and one job is selected and run via your job scheduling, and it will be run via the job scheduling algorithm. Means that suppose there was n number of jobs are waiting for your waiting state, and then as per the scheduling algorithm one of the job will be selected. Okay, so this will be happen, and via the your operating system. So operating system can do all the things, and then when it has to wait, and the operating system switch to another job. So suppose the one process is waiting for the longer time, or one process is moved to your IO operations, then other process will be get the chance. So this switching will be happen. So the CPU is sent to the for the execution for the IO state, and then it can receive the or select the another job from your waiting state to our execution state. So for their if it is a multi-programming, so all the things will be easily resolved. And time sharing, that is for the multitasking. So it is for the multitasking part, and it is for use for your logical executions in which the CPU switch the job. That is the CPU will switch the job from the frequently from one users to other users. So the job can be moved from your running state to our ready queue state, and ready queue state to running state. And your response time, that should be your less that have the some of the that is less than of the 1 seconds. Each of the users has at least one program executed in the memory. That is you know that this is called actually process. That is when the program will be executed from your memory. So each users has at least one program. So and if your several job are in the ready queue state, then and it will be run as their same time. So it is never happened that in if there is a several job is ready to run and at the same time, so it's never happened. That for that reason the CPU scheduling algorithm is there, so that they can execute it. If the process does not fit to the memory, and so it's happened, then you swapping will be happen. Swap the move from that is the in or out. So both are to perform. Then this process will be saved into the memory. and virtual memory is allows to execute the process is not completely in our memory. So these are the operating system or structure. Now this is our layout of your multi-programming system. Suppose there is a operating system is a first loaded, and there is suppose the 4 job are reduced, then one by one job will be executed. So and all the job are stored into the memory, main memory initially. And if it is a finished, then one job will it will be free from the memory. And then the operating systems, what are the operations? That is the interrupt defined by the hardwares. If there is software error will be occurs, then the operating system resolve this. So dual mode of communications, and also the important, that is the infinite loop. Suppose the some of the programs or some of the process have there is a taken the infinite loop, then operating system will be stopped, otherwise the system will be crash or anything will be happen. So operating system take care of all the things. And dual mode of operations allows the operating system to protect itself and the other systems of the component. That is, the two mode is there, one is the user mode and this is the kernel mode. So this switch conversion user mode to kernel mode and kernel mode to user mode, so they can switch on each another's as per their requirement. Suppose the user mode is right now is needed, then it is moved to the kernel to user mode. So kernel mode is actually handled by the operating systems, and your mode bit is provided by your hardwares. Okay. Now this transition from the your user to kernel mode. So in the user mode, suppose the, for example, say, so user mode means that suppose if the mode bit are our 1, that is called the user mode. If mode bit our 0 means that it is our kernel mode. So they can keep the informations to switch from the your user mode to kernel mode. So here for the example, that is a user process, one process is a user process are executing and then call the your systems. Okay, so call the systems call, then it is a trapped. Okay, so that is a it is convert to the mode bit equal to 0. Then after executions, if it is a done, then it will be switched to the our user process, move to the user kernel mode. So now the mode bit will be changed and then it will be returned. Okay, so this is a one counter is there, so they can take this. So that is the increasing and the decreasing. Pass the your 1, so then it will decrease means the 0, and now again it will be increases. Okay, so this way the scheduling will be. Now now the management process. So what there is a CPU will be taking this the process management. So you know that process means that suppose the some of the program is executed or suppose the program is there. So program means the set of instructions. Okay. Now in the suppose the in our programmer they write down the set of instruction 1, then instruction 2, instruction 3. So they have written in our some of the editor. When you execute this, so these files will be executed. Okay, right? Now this file is loaded from our main memory and initially, then one by one it will be executed. So each of the suppose instruction, or this is called the process. Now same way the another, suppose the another program this is also that this time that is also executed. So now there is a two processes are generated. Now which process will be first executed, which is our second, so that will be taken by the CPU. So now and each of the instruction will be called, or each will be instruction will be executed. So now the CPU will be utilized. And if the CPU suppose they want to store the some of the values into the memory, or they can require the some of the value from the your memory or the from the IO devices, they can access this. Okay, so they can access the files or everything. So this process, this management is also the required and the importance. And you say that is the initialization of the data. So the process termination, so it is also the very much important. So when the process will be finished their tasks, they can terminate it. If it is not terminated, the memory will be not free. So it's also the required for our tasks. The operating system task is there. So when the process will be completed, then this process, all the information will be deleted or destroyed from our memory. So this is the process, our termination process. Now the process is our passive and our active, which is the process. The program is actually passive part and process is our active part. Why the program is a passive part? Because the process is our main process. Inside the process there will be the our program is there. So if the process will get the chance to execute the CPU, then CPU can fetch the one by one instructions, and as per instruction they can allocate the memories or everything, allocate the memory or fetching the data from the memory, or the input output would be the busy, so they can perform their total operations. Okay, and when it will be the completed, so that's why the program is our passive and your process is our active part until the work not completed, the work within the systems. A single threaded process has one program counter, because we want to remember that program counter is necessary, because the one by one instruction will be executed. So which this information will be but which instruction will be executed completed, and then the which instruction will be next executed. So this counter will be take the decisions and then specify your locations also for the next which will be the executed. Now your multi-threaded process has one program, multi-threaded process has one program counter per thread. Okay, so if there is a multi-threaded, then each of the thread have the individual counters, and your typical systems has your memory process, and the some user or the some operating systems is running concurrently on one or the more CPUs. That is a concurrency. We can say that is a concurrency by your multiplexing or the CPU among the process and your threads. Then your process, your management activities. The operating system is the responsibility for their following the activities in the for their correctness for with your process management. So that is the first, you're creating and deleting both user and the system process. First create the process, or after they finish, then they delete the process both from your users as well as your systems. And suspending or the resuming the process, because suppose the some of the process is taking the longer time, so they can suspend. If it is not properly working, or the some of the error will be there, they can suspend this or resume for the waiting for the some of the holding that the another process can get the chance, because that take a longer time they can. So this will be this activity will be there. Providing the mechanism for process synchronization. So synchronization is very much important, because one by one process will be executed, so instruction will be executed. So synchronization is required, because the next instruction will be executed first, and the first instruction will be executed the second. So that will be the ambiguity or clarity will be there. That is will be create the problem. So this synchronization is very much important, because for their any your arithmetical operations or anything will be there. And then the providing the mechanism for your process communication. So communication is very very important. So which process is completed, which is not, which will be the priority is higher. So these communications will be required for the operating systems, because which is the urgency required for your process. So or better, so that will, this communication will be help the management scheme. Providing the mechanism for deadlock handling. So if there is a deadlock will be occurs, and then we can how to resolve the deadlock, or how to avoid the deadlock. So or how to synchronize the process, then the deadlock will be never occur. So they can take the decisions, or so operating system as the main part is our decision making. So they can take the decision for these handlings. Now to your memory management. So all the data in the memory will be stored from the CPU. So before and after your processing. So data is stored. So but which data will be stored, and that this instruction will be coming from our that is CPU or operating system. So all the instruction in the memory in order to execute. So one by one instruction will be executed, and they maintain their order. Okay, so that will be the, if there is a disorder, then that will be the problem will be generated for executions, or we can get the different results or different outputs, or you can get memory management. They can take the determine what is your memory, and that is actually the optimize your CPU utilizations. Okay, so this CPU utilization and your computer response to your users. Memory management activities means that they keep their track of which part of the memory are currently being used and by whom. So this is our main that is the which is actually data are accessing from the memory, so they can track their records in our your memory management systems, and take the decision, decide the which process and the data to move to the into or out of the memory. They can take the decide, and allocating and deallocating the memory space as needed. So if it is a memory space are free, they can allocate. If this process or this suppose some of the instruction or the processes complete their task, they can deallocate the memory because it is not needed, so you can free up. Or if I want to delete the some of the data, they can deallocate this. So this is very much important. Next is our storage management portion. Storage management is our when the data will be stored permanently into the memory, so that is required for the secondary memory or second storage utilizations. So but we know that the data will be stored into the memory, but in this instruction or the physical abstract of the physical representations, that user can understand the where the data is stored. That's why the file will be used. So in the file, it is actually your logical storage unit. So we can not that it is physically, we can logically represent that these are the content or these are the information, this is the instruction will be stored. For example of the suppose defined file, that is doc file, or the your programming, suppose if it's a C programming file, so that will be stored into the C programming. So each of the files has different properties, different types. They can maintain their storing, but actually the data are stored. So this information are kept into our files, where the data is stored and which type of data is stored and all the information. So this is a file representation, and each of the mediums is a that is the medium is that all of the controller device are there. They can store, that is the disk type or tape type. So we can store or we can transfer the data as per our requirement or the capacity. Suppose our use capacity is required, so we access the another device. Okay, so and your data transfer rate also the different, and the access method are also different. They can maintain this. Then the next is our file system management. So in our file system management, the file actually it is usually the organized into our directories. So in the files are stored into the or representation of the directory. So which directory file are present, so for their user understanding, so they can store the particular specific file to the some of the directory, they can access this. So this and this directory path are also important, where from there the operating system can understand the where the information are there, so they can open it. Or so actually the file is also a program. Okay, so inside that have the program, so where the data is stored, where which type of data are stored. Okay, suppose you know that this is suppose the Excel file. So Excel file has the different properties. Suppose the doc file has the another properties. So in different files are different properties. Image files, so they can store the image information of the data will be stored. So you can store into the particular directories. So all the files, different files are stored. Then operating system actually here the activities are required in the file management systems. So they can create or delete the files. They can generate the files as per their properties, or the delete. Same way your directory also they can create or delete. Preemptive to your manipulate the files and the directories, and mapping the files into your secondary directory, because the where the data is stored into secondary, so they can map. So that's why I'm telling you that in the file stored the where the data is stored and which place or which memory address are accessed, and then the next continuations. Okay, so these are all the information are kept into our file. So operating system, this mapping will be made it, and then backup files into your onto your stable. So that if it is a non-volatile, you know that. So backup your files onto your stable state. Next is our mass storage management. So it is usually for the use for your disk used to store, and where and what and would not be fit for your memory. The proper management is of your central importance. Entire speed of the computer operations hinges on the two disk subsystems and its algorithms. And operating system activities are your free the space management and the storage allocations or your disk scheduling, and so these are the mass storage management are there. And some of the storage needed but not be fast, that is your tertiary storage include your optical storage, magnetic test. So different storage device have different strategy or different arguments, also they can follow the this their strategy, and still must be your or manage, and the various actually the varies between the your VMs, that is the your write. If it is a write once, then the read many times you can read. If it is a one time, you can submit the magnetic tape or so it is not erasable. So if you write once and you read many times but you cannot write. Or another is our read write mode. So that is the sum of the magnetic at the read write mode means that if I write this, then we can next time we can write, then can first erase it and then can write. So this may happen. So read write. Next is our caching. So caching is very much I already told. So the CPU, if I want to the access to our main memory, so via the caching will be via the cache memory they can access this. So it is a very much importance, and they're performing your many levels of your computer, and it is actually the fast for the fasting process, because you know that your main memory is slower than your cache memory. So cache memory faster because there is a space is our smaller. So if fast the CPU can check that in this data or the information are present in the cache or not, and it is a that is a few, it is a partially it is are used. Suppose some of the instruction are in the past time are used. So if I get this information from the cache, then it is not needed to the search this information from the, you can move to your main memory. So that will take the time. So this time management is also the important for our operating system. So first they can search the information or the data or the instruction are present into the cache or not. If it is a present, so they can get the easily. If are not present, then they can switch to our main memory portions. So this is the for the speed up our systems. And then your faster for the storage of the your first check the it is information are present or not. Now next is the your if the cache is our smaller than the your storage devices, so I already told. And then we can suppose the then we can replace algorithm are there. So as per their replacement policy, then we can use this. This is our actually the total levels or different variant, or that is different of our memory management: register, cache memory, main memory, and disk size, and their size and their technology, which technology are used for their these devices, access times, bandwidth, and managed by the will manage this. So all the things. So you can check it. Now this is our for the multitasking process. So you know that the main memory access the information of the data from your magnetic tapes. So if it is a multitasking environment is there, so they can main memory access the disks, but the cache memory cannot directly access your magnetic data from the magnetic tape or the magnetic disks. Via the main memory they can access this, and same way your hardware registers. Okay, so they can follow and they can maintain their one by one path. Okay, so but cannot directly access from the other devices. So suppose the from the your CPU register can want to access the main memory data, so they cannot. Via the cache memories they can access this. And your multiprocessors environment is also the important for provide your cache cohesions essentially, and in the hardware such that all the CPU have the most recent value in their cache. Then distributed environment situations, even the more your complex, because the several copies of a datums can exist, and the various solutions we can cover in the another chapters. So, and there is a IO subsystems are there. Suppose the one process of the operating system is hide the particular your hardware device from the your users, and the IO subsystem is responsible for your memory management, and as well as for the cache accessing, for the cache is stored the part of the data for their faster storage, for their performance, or the spooling of the your job into that is with their inputs and to your other jobs. Then your general device driver is interface are used. Then last, your protection and security, it is very much important, because if our system are not protected, then so first the operating system protect our systems, and there are several mechanisms. Via the mechanism they can protect our users from your process or the users to their resources. Security is our required, because there have the two type of security. One is our internal, another is our external attacks. Suppose your internal attacks, suppose our external is that you know that different type of virus attack, or the worm attack, or DOS attack. So we can find out, or we can first detect this, or we can remove these attackers, because if they can attack this. Suppose the first attack is our the user identifier, so user identities. So first they can include their names, or they associate their numbers, or their via the user they can enter to our system, and then they can hamper our systems. So they can find out your user ID, okay, or all the files are stored into the systems, and same way these are the people you can do this. Now the distributed systems, that is our connected via your networks. So and via the network this communication will be happen. So that is via the local network for the shorter distance. If it is a longer distance than 1 man, so these are the network are used. And here the network operating systems are used for their management. Suppose the file sharing, or their communications among the new networks, or they can access the your file access, okay. So via the distributed they can access the distributed files, or distributed your process, okay. So we can access this. So but here the one problem is, suppose the network is slower, then you cannot access this. So that will be the major problem. Then special purpose of the system, that is your real-time embedded systems. So that is the BCR or the car or phone. So these are the embedded systems. So Raspberry Pi. So we can then there have the system is there. There is a mini type of systems, and they can they have own OS handling. So we can access these devices or these systems in a any portability is there. So portability are there. So we can access any of the places, or you can move the systems from the one place to other place. So that will be the easier, and easily you can install the systems of any of the place. There is the special purpose of the another system. There is multimedia data, that is you can store the audio or video files, as well as converted file into the multimedia systems in their systems, or we can handle the that is the other systems also. Computing environment, that is a traditional computers, okay, and there is a home network or official environment. We can access your PCs, okay, of any of the terminals, or that is the mainframe or the mini computers, and providing their patches and your time sharing. So access this. Now your computing environment, that is a client server actually computers. So this is another type of performing the network person is there. So suppose the client want to access that is the several type, one server is there, and several clients are connected to the servers. Now the client want to access to the server. So first the client send to the request to the servers, and then that is the server is busy or not. If server is free, then they can send the response. Then the communication will be established. Then the client send the some of the instruction to our server. Inside the server, that will be processed, and after the completion their task, then the server will be sent to the response to our client. They can get it. So this is our client server, actually the communications. So in the client server communications, that is your computation will be performed. So that means or we can access your database. Suppose this is called the database server. So in the server, there is a database is there. So client want to access some of the data from your database. So that is they can send the request. First the connection will be established, then they send the request, and then after the getting your proper results, then the response will be coming. Okay, so this is our computational. And then file server is also there. Suppose inside there is the file is there, and it is a shared mode. They can want to access your files, or they can store the value into the server as well as. So you can store as well as you retrieve the files from the server. Then peer-to-peer computing, that is suppose that is a P2P communications. Suppose there is only the one client communicate to our one servers. Okay, so that is not a distinguished. So so all the node are considered as a peer. Now at a time, the one client will connect it to the servers, or server can connect it to our clients, and then their communication will be performed. Web-based server and web-based computing is our that is the web is a ubiquitous. It is and it is also the PC. All the devices are you can access via our web, or we can access them on the website. So we can access our servers. So okay, so that is our web-based computing is used. Okay, thank you very much.